Hi, I'm Timon.
And I'm Stefan.
In the following 3 weeks, we will guide you on a journey through the world of AI. For the first stop of our journey, we want to have a look at common examples of AI and investigate what artificial intelligence actually is.
Most of us associate artificial intelligence primarily with movies, where AI is sometimes helpful as Kit or R2-D2, sometimes cute as Wall-E, and sometimes threatening or scary, such as the Terminator. Most of those examples seem like from a galaxy far, far away. However, artificial intelligence is already shaping our society and changing the way we live together. The world of AI has already arrived.
Let's have a closer look at some of those state-of-the-art AI applications we already see in our daily lives, such as this one. One of the most prominent examples is natural language processing, or in short, NLP. NLP is about understanding language, both spoken and written, for example in automatic translation. In the subfield of speech recognition, there are virtual assistants such as Google Now, Siri from Apple, Echo from Amazon, as this one is, or Cortana from Microsoft. They help us get things done, such as sending emails, making doctor's appointments, finding a restaurant, or telling us the weather.
Companies use AI a lot to tailor their services to their customers' needs. Netflix and Amazon, for example, use AI to make better recommendations based on the user's history of purchases, products, or movies they are interested in. They recommend us what to buy or watch. Supermarkets and stores decide which goods to have in stock. Google or Facebook use AI to present ads to us. And Uber uses AI to calculate the fare and to plan the routes for their drivers.
Smart mobility is in fact one of the more controversial use cases for AI. The rise of self-driving cars produces many questions. Who is responsible if the AI fails? And how should the AI decide in certain dilemmata, such as crash into the group of school children or the pregnant woman?
Games are another traditional application of AI. Humans have always wanted to create computer programs or intelligent machines that beat humans, for example in the Game of Kings, chess. In 1996, Garry Kasparov, the world champion of chess, was defeated by Deep Blue, the IBM machine that was able to use powerful search algorithms. Another recent groundbreaking event was when Lee Sedol, a world-famous Go player, was defeated by Google's AlphaGo system in a game that is way more complex than chess.
As we have seen, AI has an increasing influence on our daily lives. That's why it's so important to learn about AI. Only by understanding the underlying principles and ideas of AI, we are able to assess the possibilities as well as the limits of AI and actively shape our society. So, what exactly is AI? Wikipedia defines AI as intelligence demonstrated by machines, in contrast to the natural intelligence displayed by humans. Most importantly, this definition focuses on intelligence demonstrated by machines, which is distinct from human intelligence. But how does a machine demonstrate intelligent behavior? And what is human intelligence? The next definition of the Cambridge Dictionary is helping us with these questions. AI is the study of how to produce machines that have some of the qualities that the human mind has, such as the ability to understand language, recognize pictures, solve problems, and learn. We can see that in this definition, there is a focus on automating certain tasks that so far require human intelligence. So studying AI might even help us to build a better understanding of what human intelligence is. Elaine Rich and Kevin Knight take a broader view. AI is the study of how to make computers do things at which, at the moment, people are better. One consequence of this definition is that everything that computers can already do better than or just as well as humans is following this definition, not considered AI anymore. If we have a look at pathfinding and navigation, which were considered AI some years ago, but today are often considered just normal algorithms. In summary, we see that even AI researchers have no exact definition or consensus on what AI actually is. Instead, the field is being constantly redefined, such as when some topics are classified as non-AI or new topics emerge. We therefore may see AI as a collection of methods. A collection of methods that do stuff previously only done by humans. If we take a look at the history of AI, we see that the field actually dates back way to Siri or smartphones were invented, and is in a constant process of change.
In the early 1950s, when computers were as big as a room, Siri, Alexa or self-driving cars were just something out of science fiction. The field that we now call AI was sometimes called cybernetics or complex information processing. The term AI itself was coined in 1956 when a couple of researchers met at the so-called Dartmouth Summer Research Project on Artificial Intelligence. A lot of the concepts that we'll learn about in this course and that we use in AI today were developed back in the 50s and 60s. There was just one problem. Computers were a lot less powerful with regards to computational power. Therefore, computers might have been able to tell the difference between shapes like circles or rectangles, but not tell if a picture displays a cat or a dog. Therefore, the field was basically buried in snow. Something we call the AI winter. Other than a little spring in the 1980s, the field essentially went to sleep for quite some time. Eventually, in 1996, the former chess champion Garry Kasparov was beaten in chess, the game of kings, by an AI. Beginning with the 2010s, AI was on the rise again. Essentially, two developments facilitate this current AI summer. The first is the ever-increasing computing power. While the Apollo guidance computer that handled the moon landing had about the computing power of the first ever Nintendo home console from 1983, today's computers have more than 2,000 times as much computing power. The second development that facilitates AI is the increasing digital transformation and, in consequence, the availability of huge amounts of data. Whenever we like something on Twitter, play a video on YouTube, buy something online, or use an Internet of Things device, we generate data. Data is what drives this AI summer, and the digital transformation has produced tons of it.
The subject area of artificial intelligence can be roughly divided into two sub-areas. One part is called symbolic artificial intelligence, sometimes also traditional or classical AI, which deals with the representation of knowledge and draws conclusion through logic or reasoning. On the other hand, there are learning approaches that derive or identify rules, behavior, or patterns on the basis of data. In other words, machine learning, ML in short. This acquired knowledge is stored in a so-called model and can be subsequently applied in new situations or to new data. The current public perception is strongly influenced by approaches to machine learning. And ML is sometimes, wrongly, used almost synonymously with the term AI. We will learn about the differences and similarities of those approaches to AI and focus solely on the currently dominant topic of machine learning for 1 week. No matter whether machine learning or knowledge-based approaches, the field of AI is now larger and more important than ever. So after learning about the importance and history of AI, as well as the reasons for the current interest in the topic, let's have a look at our journey through the world of AI. In week 1, we will compare traditional symbolic approaches to AI with machine learning, in particular, our first paradigm of machine learning, called reinforcement learning. The second week is all about machine learning. You will explore what actually makes machines learn and experience what supervised and unsupervised learning are all about. The last week is looking at the bigger picture. We take a look at what it means for a machine to be intelligent, explore what neural networks are, and discuss implications for society. If you're a teacher, we will also share some insights and tips on how to integrate what you will learn within your teaching. Let's start our journey into the world of AI, leading you through 11 additional videos covering all the aspects that you've been waiting for. So this was it for today. We'll see us tomorrow when we'll explore how a computer can actually learn how to play a game.